Computer networks have revolutionized the way we communicate and share information. A computer network is a system that connects multiple computing devices such as computers, servers, and smartphones. This connection allows them to exchange data and share resources. Networks enable communication over geographical distances, facilitating collaboration, information sharing, and access to a vast array of online services. They have become an indispensable part of modern society, transforming various sectors including business, education, healthcare, and entertainment. The primary purpose of computer networks is to facilitate communication between devices. By connecting devices, networks enable users to send emails, make video calls, share files, and access information from around the globe. Networking has also led to the development of cloud computing, where data and applications are stored on remote servers and accessed over the internet. This has further enhanced collaboration and data sharing capability. The evolution of computer networks from rudimentary systems to the sophisticated networks we have today has been driven by the need for faster, more reliable, and more efficient communication. As technology has advanced, so too have the capabilities of networks. From the early days of dial-up connections, we now have high-speed broadband and wireless networks that enable seamless connectivity and data transfer rates that were once unimaginable. The impact of computer networks on society has been profound. They have broken down geographical barriers, fostering globalization and interconnectedness. Networks have also played a crucial role in driving innovation and economic growth. Businesses rely heavily on networks for communication, e-commerce, and data management, while individuals benefit from instant access to information, entertainment, and social networking platforms. The origins of the Internet can be traced back to the development of ARPANET, or Advanced Research Projects Agency Network, in the 1960s. Funded by the US Department of Defense, ARPANET was a pioneering network that aimed to connect research institutions and military installations. It introduced the concept of packet switching, where data is divided into small packets and transmitted independently across the network. ARPANET's success in enabling communication between geographically dispersed researchers laid the foundation for the development of the Internet. In the 1980s, the National Science Foundation established NSFNet, a high-speed network that connected universities and research institutions across the United States. NSFNet utilized TCP/IP, or Transmission Control Protocol Internet Protocol, as its communication protocol, which enabled different types of computers to communicate with each other seamlessly. The adoption of TCP/IP as a standard protocol was crucial in the development of the Internet as we know it today. The transition from ARPANET and NSFNet to the global Internet we know today was a gradual process. As more and more networks adopted TCP/IP, they were able to connect and exchange data seamlessly. The development of the World Wide Web in the early 1990s, along with the creation of user-friendly web browsers, further accelerated the growth and popularity of the Internet. Today, the Internet has become an integral part of our lives, connecting billions of devices worldwide. It continues to evolve rapidly, with new technologies and applications emerging constantly. From social media and e-commerce to cloud computing and the Internet of Things, the Internet has transformed the way we live, work, and interact with the world around us. Its impact on society has been profound, and it continues to shape the future in countless ways. Data communication is the process of transmitting information electronically between two or more points. It involves a sender, which transmits the data, and a receiver, which receives the data. The data is transmitted over a transmission medium, which can be either wired or wireless. Several key terminologies are associated with data communication, including bandwidth, IP addresses, and switching techniques. Bandwidth refers to the amount of data that can be transmitted over a network connection in a given amount of time. It is typically measured in bits per second or multiples thereof, such as kilobits per second, megabits per second, or gigabits per second. Higher bandwidth allows for faster data transfer rates, which is crucial for applications such as video streaming, online gaming, and large file downloads. An IP address, or Internet Protocol address, is a unique numerical identifier assigned to every device connected to a network. It serves as a logical address that enables devices to communicate with each other over the Internet. IP addresses are typically represented in a decimal format, such as 192.168.1.1. They play a vital role in routing data packets across the internet, ensuring that data reaches its intended destination. Switching techniques refer to the methods used to route data packets between networks. Two common switching techniques are circuit switching and packet switching. Circuit switching establishes a dedicated communication path between the sender and receiver before data transmission begins. This technique is commonly used in traditional telephone networks. Packet switching, on the other hand, divides data into small packets and transmits them independently across the network. Each packet contains the destination address, allowing it to be routed independently and reassembled at the receiver's end. Networks can be classified into different types based on their geographical scale and purpose. A personal area network, or PAN, is a small network that connects devices within a limited area, such as around a single person. Examples of PAN technologies include Bluetooth and near-field communication. A local area network, or LAN, connects devices within a larger area, such as a building or campus. Ethernet and Wi-Fi are common LAN technologies. A metropolitan area network, or MAN, covers a larger geographical area than a LAN, typically a city or town. MANs often connect multiple LANs together. A wide area network, or DWAN, spans a large geographical area, such as a country or continent. The Internet itself is a prime example of a WAN. Network protocols are a set of rules and standards that govern how devices communicate over a network. They ensure that data is transmitted and received correctly. Some essential network protocols include TCP/IP, HTTP, and FTP. TCP/IP is a suite of protocols that forms the foundation of the Internet. HTTP, or Hypertext Transfer Protocol, is used for communication between web browsers and web servers, enabling users to access websites. FTP, or File Transfer Protocol, is used for transferring files between computers on a network. The World Wide Web, or WWW, is a system of interconnected documents and resources that are accessed over the Internet. It is based on the client-server model, where web browsers or clients request resources from web servers. HTML, or Hypertext Markup Language, is the language used to create web pages, defining their structure and content. Domain names are human-readable addresses that identify websites on the Internet. They provide a user-friendly way to access websites instead of using numerical IP addresses. For example, the domain name example.com might correspond to the IP address 192.0.2.1. When a user enters a domain name into their web browser, a system called DNS, or Domain Name System, translates the domain name into its corresponding IP address, allowing the browser to connect to the correct web server and retrieve the requested web page. The WWW has revolutionized the way we access and share information, making it an indispensable part of modern society.